Hey all, it's Mr. Cassandra here. I want to review some stuff about linear equations. And then for tonight's homework, or today's homework, we're going to be converting equations into different forms. So this is just to get you familiar with the terminology. So there are three forms of linear equations. You're familiar with all of them now. The first one you're most familiar with, slope-intercept form, y equals mx plus b, where m is equal to the slope or the rise over the run, and b is the y-intercept, where the line crosses the y-axis, and the point would be 0b. So to graph a line in slope-intercept form, we plot 0b on the y-axis, and then we use the slope to generate more points. We were doing that before we started the online learning, and I think most people had a pretty good understanding of that. Then there was standard form of a line. Standard form of a line is ax plus by equals c, where a and b are whole number integers, positive or negative numbers that are not fractions. And to graph a line in that form, we made a little mini table, if you remember, where we found the x and the y-intercept. Now, I made it even easier to look at here in this review, that if you wanted to find the x-intercept, you make y 0, and then x is just going to be whatever the constant is, c, divided by a. That's it. So that's 1 point, c over a, 0. And then the y-intercept is what y equals when x is 0. So when x is 0, the y-coordinate is going to be c divided by b. And just watch your signs when you do that. And then the last form we just learned yesterday, which is point-slope form. And point-slope form is useful when you know a point on the line, and that point on the line is not the y-intercept. So it's any other point on the line. That's x1, y1. And then m is still the slope. So if you want to graph a line in this form, you did this yesterday for homework, you plot the point x1, y1, and you have to watch your signs, because if it's subtraction, then the coordinates are positive. But if it's addition, then that means you're subtracting a negative, so the coordinates would be negative. So just watch your signs. The examples do a really good job of explaining that. And you plot that point on the graph, and then you use the slope to generate more points from that point, just like you would if it was slope-intercept form. So those are the three forms of a line. And now I have a few examples for converting. So here's the first example. Let's say you want to convert something into slope-intercept form. Well, we've already done that in standard form, so I included an example for you as a reminder. You bring the x term over to the other side, make sure you change the sign, and then you divide by the coefficient of the y. And you just have to make sure you divide everything. Then make sure you simplify, reduce the fraction, and make sure you divide correctly. And if the b value is a fraction, that's fine. Just leave it in simplified form. So that's that. Now, what about point-slope form, what we learned yesterday? Can we convert that into slope-intercept form? So I gave you an example there, y minus 5 equals 1/2 times x plus 12. So the first thing you want to do is you obviously want to distribute that slope. So I drew little arrows to remind you how to distribute. So I'm going to do 1/2 times x and 1/2 times positive 12. So I end up with y minus 5 equals 1/2 x plus 6. And then obviously if I want to get this into slope-intercept form, I want to get the y by itself. So how do I get the y by itself if I have y minus 5? I do the opposite of minus 5, which is plus 5. If it was addition, you'd want to undo it with subtraction, right? And then you just simplify and you're in slope-intercept form. Piece of cake. And then, what if we want to convert something into standard form? So what if it's in slope-intercept form and they ask us for homework to change it into standard form? Well, I basically want to do what I did to get it into slope-intercept form in reverse. So I want to bring the x over to the other side, and then I want to make sure the coefficients are integers. So in my first example was really easy. If I just bring the positive 5x over to the other side, it becomes minus 5x. And obviously that's a positive y. And you're done. So I hope, they're all that easy, right? Wouldn't it be great to have a test with 20 problems like that? However, sometimes the slope's a fraction. So when you bring it over to the other side, like in example 2, Make sure you change the sign when you bring it over, but I can't leave it like that because the a and the b must be integers, which mean positive and negative whole numbers. So what do I have to do to clear the fraction? Well, I'm going to multiply by the denominator. And what's the denominator of minus 2/3 x? That's right. We have to multiply everything by 3. So if I multiply by 3, that gets rid of the denominator. So minus 2/3 times 3 is actually minus 6/3, which is negative 2x. And then I have 3 times y, which is 3y, and 3 times negative 4. So that's easy also. Okay? And one last example. What if it's in point slope form and I want to convert it into standard form? So here's an example where it's in point slope form. Y plus 6 equals 3/4 x minus 5. So step 1 is the same thing. You're going to distribute that 3/4, just like if you were going to convert it to slope-intercept form. You're going to distribute. And then, because I have those 4's in the denominator, I want to clear the fraction again, right? So I'm going to multiply everything through by 4. 4 times y, 4 times 6, 4 times 3/4 x, which cancels the 4's, and 4 times negative 15/4, which cancels the 4's. So what does that leave you with? Well, 4 times y is 4y, 4 times 6 is 24, 4 times 3/4 is 3x, and minus 4 times 15/4 is minus 15, because the whole reason why you're multiplying by 4 is to get rid of the denominator. So now I have this. So what do I want to do to get this in standard form? Well, I need the 3x over to the other side. So I'm going to bring the x term over to the other side, where it becomes minus 3x, right? But then I have to bring that plus 24 over to the other side. And of course, I'm going to do that by subtracting 24. And we're going to get the x and the y by itself. And boom, there it is. Okay? So once again, it's distribute, clear the fraction, bring the x over, and then get the x and the y by itself by doing the opposite of that. Okay? So I'm going to take a picture of the homework that you're going to have for tonight, and hopefully this lesson helps. And that's it. I miss everybody. Stay safe, be well, and I hope this is over soon.